Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In today's video I am going to discuss question number 7 of exercise number 9.2 related with chapter number 9 differential equation relevant with FSC part 2 Mathematics KPK board. So let's move toward FSC part 2 Mathematics KPK board exercise number 9.2 chapter number 9 differential equation is the name of this chapter. Question number 7 tells that determine the particular solution y is equal to f of t of the homogeneous differential equation t square y ratio which is equal to y square plus 2ty with the initial condition y of 1 is equal to 2. Move to solution. We are given with the homogeneous differential equation t square y ratio which is equal to y square plus 2ty. Also we are given with the initial condition y of 1 is equal to 2. This 1 represents x and this 2 represents the value of y. We are going to find the particular solution to this differential equation, homogeneous differential equation. So over here let's simplify this equation. So it becomes t square y ratio is actually the first time derivative of the dependent variable y with respect to the derivative of independent variable t. So t square y ratio is dy by dt which is equal to y square plus 2ty. Now divide this whole differential equation with t square. So t square cancels with t square, we left with dy by dt which is equal to, which can be written as y by t whole square. And plus this t cancels with t square, so we left with 2y divided by t. Now from over here, let's suppose I conclude, I suppose y by t is equal to v or y is equal to tv. So taking the derivative with respect to t, so dy by dt will be using product rule. So first function, derivative of the second function with respect to t is dv by dt plus second function v, derivative of the first function with respect to t is 1, so we just left with v. So the required dy by dt is equal to t into dv by dt plus v. Putting this value and this value in this differential equation to reduce into another differential equation. So dy by dt is actually t dv by dt and plus v which is equal to y by t. From over here y by t is actually v, so v square plus 2 times of y by t. So from over here y by t is actually v. So t dv by dt will be equal to v square. Shift v on the right hand side, it becomes negative v. So 2v minus v will give us a plus v. Now over here using separable differential equation, so shift dt and t on the right hand side, it becomes dt by t which is equal to shift v square plus v on this side, it becomes dv upon v square plus v. Taking independent integral on the both sides, over here take v common, we left with v plus 1 and in the numerator we left with dv. And over here integral of dt by t is ln of t, and with constant I can take ln. Now over here I will use partial fraction method. So let's suppose I consider this is equation number first. So taking the partial fraction over v into v plus 1 into dv which is equal to a by b plus b upon v by v plus 1. So taking LCM, so 1 over v plus 1, it gives us v into v plus 1 gives us a into v plus 1 and plus bv. So they can start with each other, we left with a1 is equal to ab and plus a and plus bv. From over here b is equal to 0, so this is 0, this is 0, we left with a is equal to 1. And from over here b is negative 1. So putting negative 1 over here, so over here negative 1 it cancels out with each other, we left with negative b is equal to 1, so b is negative 1. Putting these two values over here, so the integral of 1 over v into v plus 1 dv will be integral of a by v. A is 1, so 1 over v plus b is minus 1, so minus 1 over v plus 1 into dv. Taking this integration, it becomes ln of v minus ln of v plus 1. Now I simplify it further. Now we get 1 over v into v plus 1 into dv. We get is ln of v minus ln of v plus 1. So put over here. Over here, this is our original equation. So integral of dv by v into v plus 1, we get ln of v minus ln of v plus 1 minus ln of v plus 1. dv over v into v plus 1 is equal to ln of v minus ln of v plus 1, which is equal to, over here product rule will use, so c will multiply with t, it become ln of ct. Now on this side, the subtraction formula of natural logarithm will use, it become ln of first divided by the second, because over here we have subtraction sign, is equal to ln of ct. Now we taking the opposite of ln, which is actually exponential on the both sides, so they cancel out with each other. We left with v over v plus 1 is equal to ct. Now from over here we suppose y is equal to tv, so v is y by t, so put over here, because our original differential equation in form of y and t, not in form of v, so again convert it into y and t. So v is y by t, put over here y by t divided by v is y by t plus 1. This 1 can be written as t by t because it again gives us 1 is equal to ct. Shift this t to the numerator, it will cancel out with this t, so we left with y in the numerator, and over here we left with y plus t. By taking LCM, it become y plus t divided by t, and in the numerator we have y by t, so this t cancels out with t, we left with y over y plus t is equal to ct. Now this curve is passing from this point x1 and y is 2, but over here this is not x. Our independent variable in this differential equation is t, not x, so it means this one is actually our t. So put over here 1 and y2, so by putting y2 it become 2 divided by y is 2 plus t is actually 1 is equal to ct. So t is actually 1, so it becomes c. So the required value of c is 2 divided by 2 plus 1 gives us 3. So by inserting the value of c, it will give us the required particular solution. So it becomes y divided by y plus t, which is equal to ct. C is 2 by 3, so it becomes 2t by 3. Now reciprocating both sides, so it becomes y plus t divided by y, and over here it becomes 3 divided by 2t. Remember, in particular solution, the independent variable is on one side and the dependent variable is only on another side. So over here dependent variable is y, so we will make it ln. So shift y on the right hand side, it become, or we can also do cross multiplication, so it becomes 2t into y, 2 into it becomes 2t square, 3 into y, it gives us minus 3y is equal to 0. So from these two, take y common, we left with 2t and minus 3. Shift this value on the right hand side, become negative 2t square. So from over here we get y is equal to minus 2t square divided by 2t minus 3. This is actually the required particular solution, and this is the required answer.